So now that you understand Bohr's model and you know that Bohr said that you have 2 electrons in the first shell and 8 electrons in each additional shell, or up to 8 electrons in additional shell, meaning that you can have a minimum of 1 in these shells after the first one, or up to 8. And so Bohr's model is always trying to get electrons to reach the octet rule. Octet is just another word for 8 because that means stability. So you'll note that all of the noble gases are stable because they have 8 electrons in their outer shell. So every element on the periodic table wants to be a noble gas in the sense that it wants to have 8 electrons in its outer shell. So it's trying to either gain electrons or give up electrons in order to make that happen. So now that we have looked for, let's take a look at our next subject, or the third thing I want you to learn from this lecture, the electron configuration. And that just tells us the arrangement of electrons in the atomic orbital. Pauli exclusion principle said that each electron had a unique quantum number, and that the maximum of 2 electrons per orbital, with the electric spins being up or down. And so chemical properties are determined by their electronic structure. So again, I usually say someone came along and say, hey, I can represent the periodic table better than you could. And so Pauli came up with what is called electron configuration. So really, what does that mean and what does that look like? So let's take a look. So the electron configuration says that electron fills available orbitals in order of increased energy. And you have what are known as shell capacities. So in the S shell, you have 2 electrons. The P shell, you have up to 6 electrons. The D shell, you have up to 10. And the F shell, you have 14. And so if we take a look here at our example, strontium, and strontium has 38 electrons. So we'll use the electron configuration table to help us figure out what is the written configuration for it. Now, I do know that it looks strange and you've never seen it before. But as I said, everything is about a pattern. And so for electron configuration, you want to understand the pattern. So the first thing we do is that we find strontium on the electron configuration table. So I'm going to pull up the larger one just so you can see it. So strontium is here. We see it in the 5s orbital, the second box. So do you see this? I'm hoping you're following me. This is 5s, and that's Sr, strontium. If you look back at your periodic table, you can find strontium, the word, and so then you would know. Again, strontium here, Sr, period 5. Okay, so let's go back to the electron configuration. All the electron configuration wants you to do in the simplest form that I can tell you, since we are a introductory course, is that it wants you to give the roadmap of how you get here. And to do that, that just means that you have to say, what did I have to cross? What lands, what shells did I have to cross in order to reach 5s2? And so you start here at hydrogen. Hydrogen is 1s. You go on across to helium, and helium is 1s2. So you'll notice then that the first answer for strontium is 1s2, meaning we went across the 1s orbital, both boxes. So now we're at 1s2. Then we have to go back down to the next row and start at 2s. And so you have to cross both boxes, meaning you move through 2s2, and you see you have box 2s, and 2 is the superscript. Next we move through 2p, and we have to go through all 6 boxes, so it's 2p6. Next you go through the 3s in both boxes, so it's 3s2. We move on, moving through 3p, and we go through all 6 boxes, so it's 3p6. Moving next to the 4th period, You go through 4S, both boxes, so it's 4S2. Then you go through 3D, all 10 boxes, so it's 3D10. Move through the next row or the next shells is 4P, and we move through all of those, so it's 4P6. So 3D10, 4P6, and we're now on the 5th period trying to reach strontium, and we go through 5S, and we end up strontium is in the second box, so 5S2. So we've now basically written the address for strontium: 1S2, 2S2, 2P6, 3S2, 4S2, 3D10, 4P6, and 5S2. And all you did was tell the scientists, these are all the periods that I cross, all the orbital shells that I cross in order to reach strontium. It seems crazy, like why can't I just go down and say 5S2? But again, you're given a roadmap. You usually don't tell someone the last part of the directions to get to your home. You start them out from where they are and will tell them the entire directions until they reach your house or your driveway. So that's the same here. We had to start all the way at the beginning of the periodic table and tell the scientists how do we go from the beginning of the periodic table to where I want to be at strontium. All right, remember now this is just a pattern. Once you have the pattern down, you can actually see it all the time, and then it won't be such a big deal. So let's take a look at your worksheet. So I gave you this electron configuration solution worksheet. And the first one it asks you about is sodium. So the first thing you do is you find sodium on the table. Sodium is Na. If you're ever concerned, like you don't know the abbreviation for things, you then look on your PowerPoint and then your periodic table so that you can find sodium. So sodium is on the 3rd period. It's the first box. So what do we do then? We go back and we tell ourselves, okay, if sodium is the 3rd period, first box, how do I get here? From here, if I have to go to the beginning of the periodic table. And so you go back and you start again at hydrogen. Hydrogen is 1S1, moving through helium, 1S2. So now you know that you have both boxes to cover. So you're going to go 1S2. Then you're going to move down to the 2nd period. You're going to walk through 2S2. You're going to move through 2P, all of them 6. And then you're going to reach sodium, which is at 3S, 3rd period, in the first box. So 3S1. So then when you look at your answer key and it tells you that sodium, that the answer for it is, I do not know why it's not. When it tells you that the answer for sodium is 1S2, meaning we went through the first 2 boxes, hydrogen and helium. 2S2, when we went through the 2nd period, the first 2 boxes, and the 2S, then we went through all 6 boxes of 2P, and we end up in the first box of 3S, and so 3S1. So sodium is 1S2, 2S2, 2P6, and 3S1. Again, it's a pattern. Follow the pattern. It is not meant to be so confusing, but just to show you that they were doing a simple process, and it looks complicated when you see it, but it's really not. It is just a pattern. So let's do the next one, which is iron. So iron, if we find it on our electron configuration table, it's going to be in the 4th period, right here in the middle of 3D. It's 3D box 6. So let's take a look at what the electron configuration says. If I'm trying to reach iron here, then I want to start again at the beginning, going through the first 2 boxes, 1S2, going through 2S2, moving on through 2P6, then back down to period 3, 3S2, going through 3P, all 6, then moving to the next 4S2, and ending up at 3D6. So the way you go use this periodic table, that it goes from left to right, and you can't just zigzag. You have to go from left to right, and you have to walk through each period: first period, second period, third period, fourth period. So no matter where your element is, you still have to walk through the preceding periods. So if we go and look back at our answer key, it's just as I said. We ended up with, at the end, at 3D6, starting out 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d6. That means, or it tells the scientists, that I went through all of these periods and all of these orbital shells before I reached my destination of iron at 3d6. And so I'll let you see if you follow the pattern for the next 3, 4, and 5, so that you can see just how simple it is. Do not do 6, 7, 8, 9, 10, because it is the abbreviated form, and I'm not asking you to learn that right now. The last thing I wanted to point out to you when we're using this electron configuration is that it can be written a second way, where you're given the electron configuration and you have to figure it out. Well, you're asking, how do I do that, Dr. Walthall? It's very simple. You add up your superscript numbers. So here is 2, so 1s2, 2s2, 3s2, 3p4. So all of the superscript numbers, not your big coefficient numbers, but the numbers that are superscript, you add up. So 2 plus 2 is 4, 4 plus 6 is 10, 10 plus 2 is 12, and 12 plus 4 is 16. So the amount of electrons in number 11 is 16. If I go back and I look on my periodic table for the number 16, so atomic number 16 tells me that it is sulfur. And so the answer for number 11 is sulfur. And so if we move down to our answer key, we see, yes, it is. And so you want to do the next one and do the same thing. You add up your electrons at the top, which gives you then the atomic number. Then you use your periodic table to find the atomic number and write that element down. And so this is the simplified version of the electron configuration table when you're being tested on it. Again, the test is multiple choice, so I'm either going to give you the electron configuration written, and you have to add up all the superscripts to tell me which element it is, or I will give you the name of an element and ask you to choose the correct electron configuration for it. You have to remember that each shell has a different electron capacity, and so be mindful when you're choosing. You might choose one and it has the right periods and shells, but it has the wrong electron configuration information. Electron configuration, there should only be the maximum number of electrons in S should be 2, P should be 6, D 10, and F 14. So if you're choosing an electron configuration and it says D 11, then you know it's wrong, because D can only have up to 10. I hope this has been helpful for you in terms of electron configuration, and it makes things much simpler. Last thing is just the chemical properties. It's telling you that the table is divided or arranged in a particular order, and it shows that the rows, as we've talked about, are in periods. Columns are in families or groups, and they are alkaline metals, earth metals, halogens, and noble gases. And you see this when you actually look at your periodic table. Here, you'll know at the top it tells you these are all of your alkaline metals, these are your alkaline earth, your transition elements, these are your halogens, your noble gases. Then it's color coded with your non-metals, semiconductors, and metals. And this helps you out because you'll have a periodic table that's blank, but it asks you which this section here to have a letter C and say which elements are here, and you should know that those are the transition elements. And so this is how this works on an exam for you, because I know you're really worried about that. All right, the last thing is Lewis. Lewis said that, hey, I want to add my information to the periodic table. And so he came out and said that the outer electrons, that he could tell you how many were in the outer electron or the last orbital shell by telling you the numerical Roman numeral associated with it. And so he said any Roman numeral associated with the letter A tells you how many electrons are in the last shell. So for instance, boron had electrons of 5. There was 2 in the first shell, 3 in the outer shell, and you see that boron is in the third column. And so all of these have 3 electrons in their outer shell. All of these have 4 down the column. These have 5 in the outer shell. These would have 6, 7, 8, so on and so forth. And so he then went ahead and showed a dot structure for it, representing that all of these had 1, 2, and then those that had 3, 4, 5, 6, 7, and 8. And that's it. Hopefully this has simplified everything for you, and you'll be able to do well on the exam because you understand the 3 things that were being taught: how to look at the periodic table and tell how many protons, neutrons, and electrons are present; how to look at the periodic table and understand and create a Bohr's model, or see a Bohr's model and be able to tell which element on the periodic table is present based on the fact you just count up the electrons in the model, and that then tells you the atomic number. And the atomic number you can look up on the periodic table and find the element. And the last thing is to look at the table and be able to tell the electron configuration for that element. And you do that by simply using the table and starting at the top at hydrogen and walking your way down to your element, making sure you go through each period. All right. So we will end this section.